Let's talk about our third exponent law, or exponent generalization. This one is going to be about dividing exponents, or dividing powers. So the key thing you have to remember before we look at how dividing exponent works is that any number divided by itself is equal to 1. So if I have the number 5 and I divide it by 5, that's equal to 1. If I have the number 1,000 and I divide it by 1,000, that's also equal to 1. If I have an x and I divide it by another x, that's also equal to 1. It doesn't actually matter what number any of these things are. That's something that's going to be key to remember as we talk about dividing exponents. So let's look at one example, and remember, you should be thinking about what patterns do you observe. So let's say I've got 3 to the 4th power divided by 3 to the 3rd power. Actually, you know what? Let's make this 3 to the 5th power divided by 3 to the 3rd power, just for fun. So if I write this out in expanded form, what that ends up looking like is I have 5 3's multiplied together on the top of the fraction, and I have 3 3's multiplied together on the bottom of the fraction. And the reason this is helpful is, if we remember that anything divided by itself equals 1, it means that this 3 divided by this 3 is actually just equal to a 1. And this 3 divided by this 3 is also just equal to a 1. And this 3 divided by this 3 is also just equal to a 1. Now I have 2 additional 3's on the top of this fraction, but there's nothing to divide it by, so they don't cancel out and become a 1. So what I'm actually left with now is 1 times 1 times 1 times 3 times 3, with nothing on the bottom of the fraction. Well, hopefully you can see that that actually just simplifies down to 3 times 3, which is the same thing as 3 to the 2nd power. So what that means is 3 to the 5th power divided by 3 to the 3rd power is equivalent to 3 to the 2nd power. So that's the first example I'm going to show you. And remember, you're thinking, do I see a pattern here? Let's try one with x's now. Let's say I have x to the 7th power divided by x to the 4th power. Well, what that means is on the top of the fraction, I have 7 x's multiplied by themselves, and on the bottom of the fraction, in the denominator, I have 4 x's multiplied by themselves. Doesn't matter that these are x's and not numbers. An x divided by another x really is still just equal to 1. And so this x and this x also just equal to 1. This x divided by this x also equal to 1. This x and this x, when we divide them, also equals 1. So I have 4 1's multiplied by each other, and then times x times x times x, because these last 3 x's don't have any match on the bottom to divide with. So what that simplifies to is x to the 3rd power, which means x to the 7th power divided by x to the 4th power is equal to x to the 3rd power. So hopefully you're seeing a pattern with how 3 to the 5th divided by 3 to the 3rd becomes 3 to the 2nd, and how x to the 7th divided by x to the 4th equals x to the 3rd. And you can think about that pattern as I erase the board. So I'll write those 2 problems at the top again. 3 to the 5th divided by 3 to the 2nd was equal to 3 to the 3rd, and x to the 7th divided by x to the 4th was equal to x to the 3rd. So you may have noticed that really you could have gotten the same result by keeping the base and subtracting the powers. 5 minus 2 is 3. 7 minus 4 is 3. So this third law of exponents, or generalization, is when dividing 2 numbers in exponent form that have the same base, you keep the base and subtract the powers. So what this looks like as a general form is if I have x to the m and I divide it by x to the n, that is equivalent to x to the m minus n. I got a little squish there at the end. Sorry about that. I got a little squish there. So that is your third law of exponents.